So today we're going to be talking about the attributes of quadratics, more specifically the attributes of a quadratic graph. That was a swift little change. So we're going to start with what a parabola is. A parabola is the shape created by drawing a quadratic function. And the vertex of a parabola is where the parabola crosses the AOS, or axis of symmetry. Now, if you remember the graphs that we had drawn, so here's my pretty little graph right here. A parabola looks like, oh, I don't want a highlighter. There we go, pen. It looks kind of like a U shape with arrows, meaning it goes on infinitely, one direction or the other, or both directions rather. So when we have a maximum, that's going to be the highest point on a graph. So a maximum means that our y value, so we have our max right here, that's going to be our highest y value, and then our graph is going to go down because our y values are going to go down. When we're looking at a minimum, that's going to be the lowest point on a graph. So we have our minimum point and the arrows go up. So if you notice what direction the arrows are going, if we look at the graph up above, the arrows are going up, so that one has a minimum. So next we're going to look at our axis of symmetry, or AOS, and that is always going to be a vertical line, that means up and down, with an equation of x equals a number. Again, equation, x equals a number. Then we have our roots, zeros, or solutions, and that is where the function will, we also call those our rocks. Sorry, I forgot to put that on the PowerPoint. That is where the function hits the x-axis or crosses the x-axis. So if you look up on this graph up here, we have two spots where it crosses the x-axis. And so a quadratic function can have 1, 2, or possibly no solutions. Those are our three options. That's not what I meant to do. And see, this one up here has 2, like I just mentioned a second ago, or it can have no solution. So I'm going to draw 2 more graphs so that way you can see what a 1 or a 0 would look like. So let's start with my xy coordinates. So I've got both my starting points on this. First one I'm going to draw, this one has no solutions. And this one, even though it's not exactly perfect, this one we're going to say has 1 solution. So if you look very closely, this one, like I just said, has 1. It touches and then goes away. This one has 2 where it crosses. This one does not cross the x-axis at all. So the domain is going to be from left to right, and the domain of a quadratic function is all real numbers. The range of a quadratic function, so yes, when we're talking about the domain, it goes left to right. This will go up indefinitely to the up and to the left. So when we're talking about the range, that's going to be up and down, and the range, try not to zoom in. So y is greater than a number if it opens upward, and y is less than a number if the parabola opens downwards. So these, I'm going to go back to talking about our max and our min for just a second. Let me change colors just so that way stuff doesn't blend in. So maximum, it goes down. Minimum, it goes up. Let me click the pen. Nope, go back. There we go. Technology is not being very agreeable for me. So if y is less than a number, that means we start at a higher number and it goes down. So that means the parabola is opening downwards. Next, if we have a minimum, y is going to be greater than a number, it opens upwards. So the first thing on this graph that we're going to look at is A. So let me grab a highlighter so that way I can show you all the different things. So we're going to look at this purple one right here. This line, it is a vertical line. It is a vertical line. Vertical, it goes up and down. That is going to be our axis of symmetry, or AOS. It's going to be x equals some number. Again, equation, x equals a number. Next thing we're going to look at is our rocks. Roots, zeros, x-intercepts, or solutions. Those are going to be where it crosses the x-axis, which is our horizontal axis line right there. Third thing we're going to look at is our vertex. So our vertex, remember, that is the point where our axis of symmetry passes through our function. And it is always written as a point of x comma y. Now, something I want y'all to think about. If our axis of symmetry and vertex intercept each other, What do you think this x and this x, what do you think is going to be related with those two? They're going to be the same number, guys. Okay? So this point and this line have the same x. So now what do you notice about the roots and the axis of symmetry? Remember, the axis cuts it in half. If we fold it in half, it's the same. It's the same, folded in half. Okay? So now, what direction does this one open? What direction does this parabola open? Up or down? So if we make a point at our highest one, and then we make an arrow to the rest of the graph, it opens down. Does that mean it is a maximum or a minimum? So from here, that way. So that first point is a maximum. And our vertex is 1, 1, 2. So 1, 2. Next, we're going to look at our x-intercepts. We have 1, 2 x-intercepts. The first one is a -1, and the second is 3. Next, what is going to be our axis of symmetry? We already have the information for it. It is the x in a number that we have already. Hint, hint. X equals 1. Next, we have a y-intercept. We're just going to estimate on this one because it is not perfectly on a number. We're going to say 0, 1.5. Again, what is the domain? That is up and down, or left to right, sorry. Left to right is our domain. And yes, that will be all real numbers. Now we're going to look at the range, which is up and down. Up and down for our range. It's going to be y is less than 2 because the highest y value we have is 2, and then it goes down. So now I want you to look at this one. What direction does it open? Does it have a maximum or a minimum? Where is the vertex? What are the intercepts? What is the axis of symmetry? What is the y-intercept? What is the domain and the range?